So now we will talk about two different approaches how to create systems. This is not going to be a very detailed lecture about it, but it's pretty important today. So what you can see here is a table. On the left side, we have the signal flow in the table. On the right side, the physical modeling, or also called object-oriented modeling or component modeling. So the main difference is that signal flow-based modeling is causal and physical modeling is acausal. I will go more into detail on the next slide. Inheritance is also a very important part of physical modeling because your models are made of several models which are the same as classes, and they can inherit from other classes functions and functionalities. Multi-domain modeling is something that signal flow cannot do, but physical modeling can do multi-domain modeling. And there's one good point of signal flow modeling. You can see the equation of your model, which is very important for control engineers who want to set up controllers and want to know how their system behaves. So acausal and causal. On the right hand, you see a diagram of a signal flow based model. And on the left hand, you see two acausal models. So let's take a look on the causal model on the right hand. Each block of this model is an explicit function depending on the input. The information flow of each block is depending on the input. That means the flow direction of information in this model is given. On the left hand, we look at the acausal model. Upper left, there's an electric circuit. And there you see there's obviously no direction, no direction given of information flow. Each of those components contains an implicit equation, and the flow of information is basically depending on the inner solution of each component. And this implicity makes it possible to set up those component-based models. So, for example, down here on the left down corner, you see a mechanical system, and you see a lot of clutches, and left and right of those clutches, there are flanges, and they are flanged on other components. So this is real physical modeling, very intuitive if you work a little bit with it, because you will set up the system like it's actually set it up in real life. So yeah, this is a bit, now we talk about inheritance, which is a pretty nice feature of model-based design with object-oriented languages. So imagine you have a class, a model 0, and you want to create a model 1. That's another model. And you can inherit the functionalities of model 0 in model 1. That's a pretty nice thing. On the right hand, you can see we even can, that's theory. I never did it on my own, but it should work too. You can inherit model 2 in model 3, but also have the functionalities of model 0 because model 2 was inherited by model 0. My favorite example for inheritance is the chess piece, because you have a pawn, you have, I don't know the English names, the horse and the tower, and each of those is a piece with the function a piece can move. And if you inherit this chess piece class to the tower, for example, all you need is to override the move function with the specialities of the tower, for example. So the next part in the table was multi-domain modeling. And this is something special for object-oriented modeling. We have different physical domains, such as electrical modeling, magnetic modeling, mechanics, and thermal, and even much more. There are a lot of free libraries for the Modelica language. Modelica is the language we are using in Activate. I will talk about this a few slides later. And you can actually mix up the physical domains. As you see here in the picture, you can see a little electric circuit. And of course, an electric circuit, a resistor gets warm. So there's some heat transmission to the environment around this resistor. Basically, what you see here is your computer. You have resistors in your computer, and your case is getting warm. So we have a thermal system and electrical system in one model. So yeah, Modelica is the most common language for modeling with object-oriented modeling. It's a free language. It appeared in 1997, the first time, the version 1.0. The last stable release is from 2017, and you can use it on basically every platform, Linux, Windows, Mac. Yeah, and this is what we are going to use in Activate.